In this lesson, we're going to look at something that's got a lot of applications involved with it, and that's weighted averages. And we're just going to jump right into things here, looking at this example question. Say we want to know how many pounds of mixed nuts selling for $4.75 a pound can be mixed with 10 pounds of dried fruit selling for $5.50 per pound. If we want to make a trail mix that sells for $4.95 per pound. Well, what we know here is that the total um, cost, or I guess the total price of the mixed nuts um, plus the total price of the dried fruit is going to equal the total price of the trail mix. Because if we take the trail mix and divide it up into the mixed nuts and the dried fruit, the price of those things are going to come out to equal the total. So how do we find the total price of the mixed nuts? Well, it will be $4.75 per pound times the number of pounds. We don't know the number of pounds, so we're going to put X in for the number of pounds. The same way to find the total price of the dried fruit, we would take $5.50 per pound times the number of pounds, which is 10. Now, to get the total price of the trail mix, which is $4.95 per pound, times the number of pounds. And in this case, the number of pounds is going to be the 10 pounds of fruit we put in plus the mysterious amount of dried nuts we put in. So let's go ahead and solve this. We get 4.75x plus 55 equals 49.5 if we distribute the 4.95 and the 10, and the 4.95 and the x. So let's get all of our like terms on the same side. If we subtract 49.5 from both sides and we subtract our 4.75x from both sides, let's see, we get looks like 5.5 equals 0.2x. So then we divide both by 0.2. We get x is equal to 27.5 pounds. That's how much. That's how many pounds of mixed nuts I have to put in with the 10 pounds of dried fruit to give me something that's going to cost me $4.95 per pound. All right, now here we have a chemistry application. A chemistry experiment calls for 30% solution of copper sulfate. It's okay if you don't know what copper sulfate is. Just think of it as something that's dissolved in water. So, well, in this case, it's probably not water, but I'm just saying, for example, let's say you have like lemonade powder and it's dissolved in water. The more lemonade powder you put in, the higher solution, the higher concentrate you have. So let's say that Kendra's got 40 milliliters volume of 25% solution. So how many milliliters of 60% solution should she add to make 30% solution? So we know that the amount of the amount of 25% solution plus the amount of 60% solution has to equal the amount of 30% solution. And so we know the amount of copper sulfate I'm going to abbreviate that CuSO4. Amount of copper sulfate in the this is an abbreviation for that, in the 25% solution, 25%, plus the amount of copper sulfate in the 60% solution has to equal the amount of copper sulfate in the 30%. It doesn't go away, so when I add the two parts, it's got to equal the amount of the whole. So to find the amount in the 25%, we take 0.25 times my total volume. So 0.25 times 40 tells me how much copper sulfate is in that solution. If I take 0.60, 60% times 40, that tells me how much, or actually, I'm sorry, we don't know how much of the 60% solution we have. We only know that we have 40 of the 25%. The amount of 60% is a mystery. And then we have the total amount, so our 30% or 0.30 times the total volume we have, which is x plus 40. So we're going to get 10 plus 0.60x equals, and then we'll distribute this, 0.30x plus, it's 1, I'm sorry, 12. So again, let's get our like terms on the same side. I would subtract 10 and then subtract the 0.3 because we end up with positive numbers that way. And we get 0.30x equals 12 minus 10, which is 2. Divide both sides by 0.30, and we get x is equal to 2 divided by 0.30, which is going to be the same as 6.67 milliliters of that 60% solution. So we want 6.67 milliliters of the 60% solution to give us the total amount. All right, so finally we're going to look at a physics example here involving a car and an ambulance. Now, under ideal conditions, a car can hear a siren from about 440 feet away. Let's say we have a car traveling at 44 feet per second towards an emergency vehicle traveling at 74 feet per second. And we want to know how many seconds it'll take for the driver and the ambulance, for the driver to hear the ambulance if they start at 1,000 feet apart. So right now they're 1,000 feet apart. We want to know how many seconds it'll take them to be this 440 feet apart. Now this distance is going to be the distance the ambulance covers, and this distance is going to be the distance that the car covers. Now what we know is that the distance that the ambulance covers plus the distance that the car covers is going to be equal to the distance that they both cover together. So you can write that like the ambulance distance plus the car distance equals the ambulance plus the car distance combined, obviously. So how we can write this is, we know that distance is equal to the rate or the speed times the time. So we can say the rate times the time of the ambulance is going to be 74 times t. The car's rate times time is going to be 44 times the same amount of time, because when they reach that distance of being 440 feet apart, that time is going to be the same. And then the distance that they combined travel, what we'll do is we'll take this 1,000 feet total that they traveled and take away that little 440 feet chunk, and what we're left with is actually 560. But I'll write it this way so you see what I'm talking about. So we end up with 74t plus 44t, which looks like it's going to give me 118t is equal to 560. So if we divide both sides by 118, we're going to end up with a time of about 4.7 seconds. And that's all the examples we're going to go over for weighted averages. I know this can be a very challenging subject, but just remember kind of the key of what we're doing is we're figuring out what value of the total can equal to the two values of the individual parts. Like in this one, we figured out the total distance they traveled and then made that equal to the individual distances they traveled. So hopefully with some practice, if you don't have the hang of it already, you'll get to the point where these are a little less daunting.